Hello, welcome to m251 Calculus 1 here at Cañada College. My name is Lapuz and I'm the instructor for the course. In this video we will go over section 1.1, the review of functions. Just as an overview for this section, we're just going to review some function basics, and some of the things that we're going to look at in our function basics are the basic definition of a function and the idea that the function takes in an input and produces a unique output. In doing so, we establish a definition of the domain and the range. The domain is a set of all inputs. The range would be the set of all outputs. Now we can signify this with a Venn diagram graph or those bubble graphs. We can also look at this as points on a graph where you have the independent axis is the horizontal axis and the dependent axis is the vertical axis. To better get a view of the idea of a graph, we start with a table, so we can express a function from a numerical point of view using the tables. And in these tables we see the set of inputs and outputs as a two-column table. I know we have 4 columns there, but it's actually 2 columns that's divided twice as long. And then you plot those points and you just connect the dots to produce your graph. Now graphically we can also take a look at a function and or a relationship between 2 variables x and y, and then be able to tell if y is a function of x. So we have this thing called the vertical line test, where if you draw a vertical line anywhere and it passes through no more than 1 point, then you have a function. If it passes through, if you draw a vertical line and passes through more than 1 point, that means you have one input that would produce 2 different outputs, a non-unique output. And so when you have that, it's no longer a function. And so the vertical line test is an important graphic way to check whether something is a function or not. All right, once we got the basics of functions, we're going to take a look at some examples of functions and then creating new functions out of them. And the basic idea behind creating new functions algebraically is to use our regular binary operations where you combine 2 things. We add, subtract, multiply, and divide, and those are the basic ways of combining numbers. And so that would be our first set of expanding our functions to look at the sum of functions, difference of functions, the product and quotients of functions. And the quotient of functions, since we are studying the idea of domains, we have to make sure that the denominator for a quotient does not equal to 0. We have another way to create a new function given old functions, and this is our new way that's not, the standard binary operations that we've been doing with regular numbers. Here we have the idea of a composition. So we compose 2 functions, f and g. We say g composed with f to say that g is going to be a function of x, but we're going to put in f of x in there, the inside function. And what that means is that our innermost function f will take in your domain, and then whatever you get there as your range, as your output, you put that into the g function, and then you get your range of g as well. And so this is the graphic representation of the composition of functions. Basically, when we compose functions, we're going to work from inside out, just by putting in those values into the whatever function we're dealing with. And this is an example of a composition of 2 functions, but you can really compose a function within a function within a function. And we'll see that deeper composition when we start taking a look at one of the basic rules for derivatives later on. All right, finally we're going to study some symmetry. Symmetry just helps us kind of the idea of visualizing and relating the numbers with a function. And sometimes symmetry will become important for us because we're going to be able to find some more information about the function, or deduce some information about the function. And so here are a couple of examples of functions and their graphs. We have x to the fourth minus 2x squared minus 3 as one function, and then x cubed minus 4x as our second function. As you can see, there's some symmetry going on here. The first example is symmetric about the y-axis, and we say the second example is technically symmetric to the x and the y-axis, and so we say that's symmetric about the origin. It turns out that these two special symmetries have a name for them, and the first one, when it's symmetric about the y-axis, is called an even function. So that means whatever is happening on the positive side of x, we're going to see a mirror image happening on the negative side of x as well. The symmetry about the origin can be described as an odd function. Whatever is happening in one side of the x-axis is going to happen on the other side of the x-axis, but the sign is also changed. And so we can see that according to the definition, our first example is an even function, our second example is an odd function. Now when we're dealing with polynomials, we can also look at the powers there. X to the fourth, x squared, and 3 is a constant, but you can also take a look at that as having x to the 0 power, which is 1. Versus the second example, we have x cubed and an x to the first power. So with polynomials, if all the powers are odd or even, then the functions are going to be odd or even. If you have a combination of odd and even powers, then your function is probably going to be neither odd nor even. And so we'll get a taste of that in a few sections when we start dealing with the polynomials. But when we start looking at other functions, we're going to use this test, the definition, for being able to tell if something is odd or even, or, in other words, symmetric about the y, or symmetric about the origin. Okay, so this is our quick overview of section 1.1. We'll dive into it. We'll do some problems, we'll do some checkpoints, we'll do some homework and see how we do. And we're just refreshing ourselves with the idea of functions so we can dive deeper and be able to play around and manipulate them. All right, good luck.